Hello everyone, welcome to Gradeup. So today we are here live for some of the MCQs discussion. Okay, so basically we have started this Gearup JE course as a free YouTube series for our RRB and SSC preparation for mechanical engineering. Okay, so moving ahead into this one, we have some of the questions, around 10-12 questions for the day. Okay, so let us see what are those questions, but before that I will wait just for 1 or 2 minutes so that more number of students, more number of viewers can join us. Okay, so just waiting for 2 minutes and then I will begin with this. So good evening all of you, and I welcome you all to this session of the important MCQs discussion, the session of Gearup JE 2.0. Okay, sound quality not good. Now is it okay? Now is it a bit better? Okay, so now is it bit okay? Yes, okay. So I think I shall begin with the questions. So this is the question number 1 of the day. This is from the subject of, you can say, heat transfer. Okay, this is the subject of heat transfer, and now you have to give me the answer. The concept of overall heat transfer is used in the heat transfer in the case of conduction, convection, radiation, or combined mode of heat transfer of conduction and convection. So you have to tell me this one, that concept of overall heat transfer, or you can say overall heat transfer coefficient, which is written as U, this is used in which case? This is used in which case? You have to tell me about the overall heat transfer, that is U. Okay, so tell me the answer. The voice is okay from our side. Okay, the voice is okay from our side, there is nothing of that sort, any issues. Okay, so combined mode, yes, in the combined mode it is done. Yes, U is used in the form of combined mode. Okay, so you know that 1 upon U is basically given as 1 upon H1A plus that is of L upon K1A of this sort. Okay, so this basically U is used in the case of combined mode of convection. This is used for convection. This is the heat transfer coefficient, and this is the K1, that is your conduction, that is conductivity. Okay, hello, now is it okay? Yes, we are resolving the sound issue. Now is it okay? Okay, great. So now coming back to this question, this U, that is the overall heat transfer coefficient, is used in the combined case of combined modes of heat transfer of conduction and convection. Okay, is it okay with this question, this answer? So moving on to the next question. This is the next question. It says this is the subject of strength of materials. Okay, strength of material, the question of principal stresses, question of principal stress. It says a body is subjected to a pure tensile stress of 80 units. Pure tensile stress of 80 units. The maximum shear produced in the body at some oblique plane due to the above is, means there is an plane of a principal plane in which there is only a tensile stress of 80 units, and on any oblique plane due to this principal stress of 80 units we have to find out the maximum shear. So what will be that? That is simply, you know, that tau is given by this sigma. Suppose let us say it is 1, so tau max equal to sigma 1 by 2. Sigma 1 is your value of this 80 divided by 2. You get the answer as 40 units. Answer as 40 units. So option C is your right. No, not 80, it's 40. It's 40. Yes, it's 40. Okay. So got it, everyone? 40 is the right answer. Okay, now moving ahead with the next one. Next question. It says, see, the number of links in a planar mechanism with revolute joint having 6 instantaneous centers is. In the last class where I was discussing the questions of the eye center, there I have given you the number of links, and there I asked you the eye centers. But here it is the way the other way around. The number of eye centers has been given to you as 6. Okay, and you have to find out the number of links. Tell me the answer for this one. See, it is given, you know, the formula n minus 1 divided by 2 is equal to eye center. So here it is given as 6, and where n is your number of links. Okay, n is given as your number of links. So from here you can write n into n minus 1 will be equal to 12, or from here you can write, just write it in this way, n into n minus 1, this becomes equal to 4 into 3. Okay, 4 into 3. So from here you can write n equal to 4, or from, if you take this one also, you will get n minus 1 equal to 3 or n equal to 4. So correct answer is your n equal to 4, that there are 4 links, and 4 links makes 6 eye centers or instantaneous centers. Correct? Correct? Any problem into this one, anyone? Or you can make the quadratic equation from here, that is n square minus n square minus n minus 12 equal to 0. So you will get n square minus 4n plus 3n minus 12 equal to 0, or you will get n into n minus 4 plus 3 common from here, n minus 4 equal to 0. From here also you will get n equal to either 4 or n equal to minus 3. Minus value we cannot use, so n equal to 4 is your answer. Correct? Now moving on to the next question, question number 4. Which of the following parameters has a unit of meter square per second? You have to tell me which of the following parameters has the unit of meter square per second. Kinematic viscosity, thermal diffusivity, mass diffusivity, or all of the above. So yes, D is the right answer for this one. All the kinds of viscosity, kinematic viscosity denoted by nu is equal to mu by rho. This also has the unit of meter square per second. Thermal diffusivity has also the unit of meter square per second, and mass diffusivity also has the unit of meter square per second. So all of the above is the correct answer for this one, option D. Okay. Now moving on to the next question. That says, for a spring mass damper system with a spring mass of 3 kg, this is the mass of the spring that has been given to you. Spring mass has been given as 3 kg, and it says stiffness is 1000 Newton per meter. So stiffness is K, given as 1000 Newton per meter. Okay, and the attached mass is 9 kg. Whatever the mass is being attached, that is equal to 9 kg. So you have to find out the natural frequency of the system in radian per second. Okay, in this case, generally what happens in the natural frequency is omega n given by K by M simply, but here in this case the mass of the spring is also given, so this is also is to be included. So what we do, ms by 3, this is the standard formula for this one. Okay, so just substitute the values, you will get K is equal to 1000 divided by mass of the system is given as 9, the attached mass is 9, plus 3 is your mass of a spring divided by this 3. You will get this value as 3 by 3 is 1. 1 plus 9 is 10. So you will get this as 1000 divided by 10, or this will become root 100, and root 100 is nothing but 10. So 10 radians per second is your answer. That is option B. Correct? Option B is correct. Option B. Okay, because I am seeing that many of you are giving the wrong answers. So the reason for this is I can make out that you have left this portion. Okay, in the so in the all the cases where the mass of the spring is also given, so that is also to be taken into consideration with this thing. That is K over M is the mass, that is the attached mass, and MS is the mass of a spring divided by 3. Just add it to this, get the total mass, and divided it by K and take the root. So you will get the natural frequency of the system in radians per second. So 10 is the answer. 10 is the answer for this one. Okay. 10 is the answer for this one. Is it okay now? 10 is the answer. Now is everything okay? Shall I move on to the next question? Okay. Okay. See the next question now. Now let's talk about the herringbone gears. So this topic or this question comes from the theory of machines. Okay, from the topic of gear. So herringbone gear. What is a herringbone gear? You must know the definition of herringbone gear, then this question is done. So tell me, what about herringbone gear? What is your herringbone gear, also known as? Herringbone gear. Tell me fast. Herringbone gear. Yes, absolutely correct. Herringbone gear is a double helical gear. Okay, double helical gear. So double helical gear means this way the construction looks like. Okay, this way. These are the teeths, and both there are opposite hands teeth in this way. Okay, so the total thrust, the thrust for this one goes this way. So it has two components, this and this. Okay, in this the thrust goes this way, so it is the component goes this way. So this and this cancel out the axial thrust, because this is the kind of shaft on which this gear is mounted. Okay, this is the shaft. This shaft rotates, the gear rotates. So these two makes the axial thrust or axial load equal to 0. Okay, so impose no thrust load on the shaft. So this is the correct answer, option A. On the same lines, we have called one more thing that is known as, in the chapter of bearing, we have taper roller bearings. Okay, this is just a analogy I am trying to develop. That is a taper roller bearing. We have the taper roller bearing. So taper roller bearing also uses that same kind of concept, that on that if we use two taper roller bearings on the shaft, so they cancel out the axial thrust. Okay, correct? Is it okay? So herringbone gear impose no thrust load on the shaft. No thrust load on the shaft. Is it okay? CB22 batch is already available, is already live. You can do one thing, you can just see the description of this video. Okay, on the description you can see that there is a course, the link is given. So you can start that course, the free trial, you can start from there. Okay, you can do it. You can start your free trial now, because it is already available, the course is already live, so you can go and start that. Okay. So now moving on to the next question, it says, in a solar air conditioning system, 1 kg per second of ambient air is to be preheated by the same amount of air leaving the system. Okay, and it says a counter flow heat exchanger having an area of 25 meter square with overall heat transfer of 100 watt per meter square Kelvin is used for this purpose. Assuming Cp of air as 1 kilojoule per kg Kelvin, the NTU of heat exchanger is, this is exchanger, NTU of heat exchanger. First of all, you come to know that this is the question from the topic of heat exchanger. Okay, then you have to find out NTU. It's a basic formula for NTU is known as number of transfer units, that is given by UA over Cp. Okay, UA over Cp. Cp is basically your heat capacity, that is mass mass multiplied by the specific heat capacity. Okay, so in this case U is your overall heat transfer coefficient given as 100. Okay, area is given to you as 25 meter square, so just put it here 25 divided by Cp. Cp value is 1 kilojoule per kg Kelvin, and all these values are given in terms of watt, so you have to convert it into joule. So that will be 10,000, sorry 1000 means 10 to the power 3, 10 to the power 3 joule per watts. So this and this goes off, this and this goes off, so you are left with 2.5. So the NTU for this one is, the number of transfer units is 2.5. Correct? A is your right answer for this one. Any problem, anyone? Or I move on, or shall I move on to the next question? Okay. So now moving on to the next question, it says the slope of shear force line at any section of the beam is also called as. Slope of shear force line. This is the question we are getting from the topic of SFD and BMD, that is shear force and bending moment diagram. It says the slope of shear force line. Suppose shear force is denoted by F, so we have to find out dF by dx is equal to what? dF by df is equal to what? Yes, it is equal to the rate of loading at that section, rate of loading, or you can say W, correct? And if you find out the slope of bending moment diagram, it gives you shear force, correct? Shear force. The slope of bending moment diagram gives you shear force, and the slope of shear force diagram gives you loading, correct? So B is your right answer for this one, rate of loading at that section. Is it okay, everyone? Now, moving ahead, next question, 9th one. The value of Prandtl number for air is about. You have to tell me the value of Prandtl number for air. The value of Prandtl number for air. Prandtl number is basically a dimensionless number which relates the heat transfer and the fluid transfer. The fluid flow and the heat flow is determined, the relation is determined by the Prandtl number, in which we determine about the boundary layer, the hydrodynamic boundary layer and the thermal boundary layer. The relation is developed using the Prandtl number. So you have to give me the values. For air it is saying, okay, please remember, for air it is saying. For air, no, for air the value is somewhat around 0.71. So this becomes your correct answer. For air it is talking about, yes, 0.7, 0.71, somewhat the values are closer to this. So for this one, the correct answer will be the value of Prandtl number for air is about 0.71. Correct, 0.71. So B becomes your correct answer for this one. Okay. So now moving ahead with the next question. The impact strength of a material is an index of its impact strength or impact loading. Basically, we can say that impact loading is useful, or impact loading, whenever there is an impact loading. So which property is becomes more important? Which property becomes more important during this? Yes, toughness. And what is toughness? Toughness. How you will find out the toughness from the stress strain diagram? Toughness is given by, how you will find out the toughness? Toughness is given by area of load versus deformation curve, load versus deformation curve, load versus deformation curve, total, basically total area of this up to failure gives you the toughness. Okay, yes, up to the fracture point or total you can say, correct? Area of stress strain diagram up to fracture. No, that is load versus deformation curve. Area of stress versus strain diagram will give you modulus of toughness, correct? Modulus of toughness. See this, let me explain this to you. See, this is your load, this is your deformation. Say this is your deformation. So load versus deformation will give you, this is somewhat like this, the curve goes somewhat like this. Okay, so up to fracture we can say. So load versus deformation, so load into deformation divided by area into delta L, that is per unit volume. So this is your toughness, and this is toughness per unit volume, that is nothing but modulus of toughness. Okay, so you can see here that P by A becomes your stress, and delta by delta L, that is your total, means deformation over original length, becomes your strain. So this is your stress versus strain diagram gives you modulus of toughness. Okay, this gives you modulus of toughness. Please remember this. Okay, this is important concept. This gives you modulus of toughness, whereas the load versus deformation curve, the total area up to fracture or up to failure, gives you toughness. Okay, energy, strain energy concept. Strain energy is nothing but strain energy is the total energy. Yes, strain energy is basically the total energy that is being absorbed by the system when the work done on the body tries to deform it. That is known as strain energy, and these are all the strain energies that we are calculating. Okay, basically there is resilience. Okay, resilience, modulus of resilience and all those things, the proof resilience. So that we have covered in a greater detail in our classes. We are covering it. The subject of strength of materials is being covered and all other subjects are being covered in a greater detail. So if you want, you can just start your free trial of the course. The link is given in the description below. Okay, so now moving ahead with the next question. It says the temperature at which the black body emission becomes maximum corresponding to a wavelength of 8 micrometer is. Basically this is the question of radiation. This is the question of radiation. It uses a law. First of all, tell me the name of the law which is used in this question. How you will try to solve it? First of all, give me the law. Very important law related to radiation. Give me the name of that law. Then we will proceed. This is a very simple one-line question. Okay, just give me the name of that law first, then we will move ahead. Okay, tell me. No, not a Stephen Boltzmann law. Sorry, not a Stephen Boltzmann law. Stephen Boltzmann law is not only not only the law in the radiation, and also it is not applicable everywhere. This is something different law. This law is, anyone else is trying? Yes, it's a Wien's law, or you can say it's a Wien's displacement law. Correct. Wien's law or Wien's displacement law is correct for this one. Wien's displacement law, absolutely fine. It says this, that is maximum, the maximum wavelength multiplied by the temperature at that at which it is attained is given by this constant this constant value of 2898. Okay, 2898 mu m, that is micrometer into Kelvin. Okay, yes, 2900 is also correct, and 2898 is the correct value or the precise value, you can say. So delta max is given to you as 8 micrometer. So just put it 8 micrometer multiplied by the temperature, and 2898. If you bring this term here, you will get the value of temperature as exact value. You will get this one, that is 362.25 Kelvin. Kelvin you will get. Okay, don't write it in degrees Celsius. This one will be wrong. Correct. C is your right answer for this one. Okay, C is the right answer for this one. Any problem? This is a Wien's displacement law. Okay, not the Kirchhoff's law, not the Stephen Boltzmann law. Stephen Boltzmann law said that the MSF power is equal to sigma into 10 to the power 4, where this is your Stephen Boltzmann law having the value of 5.67 into 10 to the power minus 8 watt per meter square K to the power 4. Correct? And your Kirchhoff's law says that when the bodies are in thermal equilibrium, its absorptivity is equal to its emissivity. That is the Kirchhoff's law. Okay, this is Kirchhoff's law. Kirchhoff's law said that when the body is in thermal equilibrium, that means that when it is in thermal equilibrium with its surrounding, the amount of energy being absorbed is equal to the amount of energy being emitted. So that means your absorptivity is equal to emissivity. That is Kirchhoff's law. Got it? Is it correct? Is it okay, everyone? This is your Kirchhoff's law. Okay. So now the last question of the day, I think this is the last question, or let me see. So let us do this question. It says compression member always tend to buckle in the direction of compression members. Compression members, we say that this is again the question of SOM. Okay, those who are familiar with this, they says no, 12A is absolutely wrong. SOM, and this is from basically the chapter of columns and struts. Those who are familiar with this, it's great. Those who are not, it's the topic of columns and strut that we are dealing with, because it states the compression members, and compression members in the vertical direction are known as columns, and the compression members in any other orientation are known as strut. Okay, that is the basic difference between the columns and the strut, and in that they always tend to buckle in the direction of least radius of gyration, which is determined by the slenderness ratio. Slenderness ratio is given by the equivalent length divided by the K minimum, that is least radius of gyration. There is a concept of slenderness ratio that is being used, and slenderness ratio is defined by LE by K minimum, where this K minimum is nothing but your I minimum, that is minimum moment of inertia divided by your area of root. Correct? PC equal to pi square EI by LE square. Absolutely correct. That is, you have given me the formula of Euler buckling load given by pi square EI minimum over LE square. Okay, LE square, where this LE is given to you as alpha into L. This is known as your length fixity coefficient, and 1 by alpha square becomes your N. This N is your end fixity coefficient. Correct? So now is it correct? So the correct answer for this one is least radius of gyration. So now the last question of the day. It says a car starting from rest moves along a curved road of radius 150 meters. Suppose this is a curved road and the car is, this is the center, this is your radius of 150 meter. The car is moving into this one. Okay, and the car attains a speed of 72 km per hour in 20 seconds. Okay, so this speed is 72 km per hour. So 72 into 5 by 18 will give you this value 4. This is your 20 meter per second. Correct? 20 meter per second in 20 seconds. Okay. So what is the normal acceleration in meter per second square at t equal to 10 seconds? So first of all, you know that this is going in a curved road. So it will have two kinds of acceleration. One is your tangential and one is your normal. That is this one. Okay. This is given by simply your alpha into t, and this is given by v square by r. Okay. V square by r. Correct? So you have to find out this one. So first of all, you have to find out the velocity at, this one, velocity at 10 seconds. Okay, so how to find out the velocity at 10 seconds? See, that says that it starts from rest, so u become equal to 0. Your v you have to find out, and your t is given to you as 10 seconds. Okay, but see, in this case you cannot use the v equal to u plus at. You cannot use this. Why? You will not be able to use it because you don't have the value of a and you don't have the value of u. So better is that you can see that this is the case of a uniform motion. So the velocity versus time curve will be very helpful here. The velocity versus time curve, this is a linear graph. So if this is the value that at 20 seconds you get the velocity as 20 meter per second. Okay, so at 10 it will be equal to 10. At 10 seconds the velocity will be 10. So this v will become equal to 10, and the normal acceleration you will get, normal or radial acceleration will be 10 square divided by your radius, that is 150. So this value you will get as 100 divided by 150, or this will be 2 by 3 or 0.667. So C is your correct answer. Okay, is it okay everyone? 0.667 is your correct answer for this one. Is it okay or not? Okay, so that's all for the day. These are some important questions, some basic kind of questions which will give you the idea about the level of the JE level examination, the SSC and RRB JE. Okay, so now you have to fasten your seat belts for the, now just gear up, now focus and everything for the CBT 2 exam. So those who haven't still got the course, who haven't got our paid course, the Focus JE Mech course, what you can do, you can go and watch the description below. You can click on the description. There is a link given for that. You can just start your free trial today and you can see that what are the courses, what will be the things that we are giving to you there. Okay, so tangential acceleration will be simply equal to your change in velocity or the change in speed. That is basically a change in speed divided by time. Okay, change in speed divided by time, that will be simply equal to 1, because your velocity in time of 10 seconds, velocity in times of 10 seconds is changing from 10 to 20 in 10 seconds. So change in velocity, that is your speed, magnitude of velocity is speed, and that is divided by 10 will give you 1 meter per second. Okay, so just go and have a look at the paid course, the Focus Mech JE course, and start your free trial today. So see you in the next class. I hope you are enjoying this Gearup JE 2.0. So see you in the next session. Till then, thank you, take care, goodbye, and prep smart, score better, go Gradeup. Thank you.